we're leaving. It went ka-chunk, 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 ka-chunk. So over the space of 3 months, we had 62 earthquakes over magnitude 5.
Wow.
One earthquake over magnitude 5 will get your attention. 62 caused a lot of damage inside of the caldera in the park. So we used to have a building out there. You can still see the outlines in the light color concrete, the old Jagger Museum. We had to take those buildings down. The outsides, not too bad. The insides were a complete mess. There is one surviving building that was back from the edge, and that's the bathrooms. They're working on rebuilding those. Not done yet. So anyway, you can get an idea of the damage up here by looking at the walls. If you look at the walls over here, the stone walls, you notice that the mortar, the concrete that's holding them together, is dark color. So it's aged, it's picked up a lot of stuff over the years. The lighter color stuff is the repaired walls. And you can see some places where it's a mixture of repaired and dark. So if it did that to stone walls, you can imagine what it did to the inside of buildings. There we go. Park had to be closed for months. We have been recovering ever since and continue to recover. I live just a little over 3 miles away off in that direction, and it was hard to get a good night's sleep because we had a lot of earthquakes magnitude 3 above. We had about 50 of those every day. So I did develop the ability to sleep through a magnitude 3, but I've never developed the ability to sleep through a magnitude 5. And oddly enough, we had almost no 4s. It was either 3s or lower, or these magnitude 5s where it would ka-chunk, go down. So, and then in 2020, it started erupting again. Oh, incidentally, it had dropped so far down, 500 meters, 1,600 feet, you could not see the bottom. Since then, the eruptions have filled in about 90% of the drop. So that gives you an idea. So it was not just that deep, it was 10 times that. You couldn't see the bottom. But going forward in 2020, we started to have eruptions that filled it all in. Well, not all, but a lot of it. And so now you can see the bottom from anywhere around the rim. Recently, just 2 days before Christmas, out of the side of the volcano over there, where you see all the big steam plume going up, we started to have a fountaining eruption. So shooting lava way up in the air. We have had 32 episodes of fountaining lava. Usually it's a few hundred feet. The most recent one was about 300 feet tall. You would have seen the top of it anyway from here. The tallest one was 1,200 feet tall, and you would have had to look up to see the top of it. So we expect another one. That was 9 days ago. We expect another one in about a week or so, plus or minus. I know everybody says, "Oh, I came at the wrong time." We just got to stay longer. You stay another week or so, it'll happen, or come back. One of the things that happened is that it put out a big lava flow, covered up about half of the crater down there. And so the smooth stuff with the gases coming out down there, that's 9 days old lava. So you're seeing some of the most recent land in the world. You also notice that the gases are coming up. That's because underneath it's still liquid. So it's sending up gases, mostly steam, some carbon dioxide, and the blue color comes from sulfur dioxide. And that's the stuff you don't want to be near. So if you're downwind of that stuff when it's erupting, puts out a lot of sulfur dioxide. Sulfur dioxide interacts with water to form sulfuric acid. You would be slowly dissolving. Not so fast that you couldn't get away, but you know, it still wouldn't be pleasant. So that's the story of the caldera and the crater formation, and bringing right up to present. But if we also look for cultural connections, who saw the caldera collapse? Well, it wasn't the Europeans, they weren't here yet. It was the Hawaiians. And they developed myths and stories. They had an oral tradition that goes back centuries. So the collapse in 1490 was documented by the stories told by the Hawaiians. Now, they developed a set of stories that we would recognize as myths. And the myth is that Pele, our volcano goddess, Pele Honuamea, was having a battle with her younger sister, Hi'iaka. Hi'iaki Ikapoleo Pele. And Pele had sent Hi'iaka out all the way to one of the outer islands to fetch back Prince Alohiau, who was Pele's betrothed, let's say. And it took too long. So Pele got upset when Hi'iaka and Lohiau got here. There was a big battle, and Pele had done some bad things. Hi'iaka was upset, and so they started battling. Now, that's just a myth, right? Except that the description that comes of the event is still useful today. Why? Because it gives us some hints about how the caldera formed and what was going on. It describes explosive activity. It describes some of the interaction of water with the lava, which of course gets explosive and a lot of steam and ash comes out. So when there is a physical description of something happening in the myth, some of the geologists take a look at that and match it up with some of the physical evidence that we collect from around here, and it matches. Okay, the Hawaiians were great observers of their environment, and although they told a big story about it, the descriptions match up, and so that's pretty cool. There used to be a road that went all the way around, Crater Rim Drive. Not all of it is there anymore. If you look over there, you'll see a little bit more than halfway down the cliff, there's a ledge clinging to the cliff. Just to the right of center on that ledge, you have a road. The road used to be connected up at the top. In fact, the whole ledge used to be up at the top. And in the other direction, the road used to go to a big old parking lot that was on the side of the old, much smaller, Halema'umaʻu. And so the collapse ate the road. The road and the old parking lot are now down underneath the lava.
So how do you know when it's close to erupting again? Like
Good question. How do we know when it's close? Okay, well, I was describing that the inflation as the pressure comes up, that's part of it. Another part of it is that, well, we have webcams looking at that all the time. There are 3 live webcams looking in there. One of the webcams is just above It's just on the cliff, just above the vents. And so when you start to see some glow, that means the lava is close enough to the surface to light up the steam. And then as it gets closer, you start to see little spits of spatter for lava. And so that's another good indication that it's getting quite close.
So maybe days before you start seeing
Yeah, maybe a day or two before. Yeah.
How do you know that it's coming in 7 days?
I'm sorry?
How do you know that it's happening in 7 days again?
Well, because there's a pattern, okay? It has dropped a certain amount. We think the pressure is going to come back up to roughly where it triggered the last time. And so if we look at how fast the eruption is coming up, we say another 7 days should be up at about the point where it should trigger. Now, that's approximate. It can be a couple of days in either direction. Okay?
Because I was thinking, can I call your center next time and see if it's happening?
Well, don't
And
call
then
me.
plan my trip?
Okay? Because I get all my information from HVO, Hawaiian Volcanoes Observatory. They put out a daily update with a daily estimate as to when they think it will next show up. There are 3 live webcams, so you can look at the glow coming up and some of the spatter. That would be what I would do. I also look at the pressure records and say, well, is it close to where it went off the last time? Okay, and if it is, pretty close. But we generally don't have exact estimates, so it could be off by a day or two in either direction, because sometimes the pressure does some little glitchy things as it's coming up closer to the top. I don't know why that is. I mean, I have some ideas why it might be, because as the pressure comes up, the lava can escape out to the sides through small pieces, so that can delay the fountain. But it's also true that the flow from underneath is not steady. Okay, not too bad from being steady, but it can be a little variable, and the amount of gas dissolved in the lava, which is driving all of this, is also a little variable. So we have a lot of ways that you can have a couple of days either direction, either earlier or later. But as it comes up, you start to see the spatter. That's a good indication that it's maybe a day or less away.
You can see that.
Pass some of these around. This is reticulite.
Light.
Quite light.
Thank you.
Okay. If it breaks, don't worry about it. We have lots.
Okay, thank you.
Okay. Now, reticulite is volcanic foam. By volume, it's mostly gas. Practically all the weight is the rock. So we'll see if anybody else wants to have some reticulite. Okay. You can just put it down on the rock ledge. I'll collect it. And it forms because you get a glob of lava. It's under high pressure, has a lot of dissolved gas in it, comes up and gets shot up vertically, and the gas immediately starts to make the lava, the liquid rock, expand. And so it's like a cone forms. But at the same time, because the air is so cold relative to the lava, it freezes, it flash freezes. And so that captures the gases right there. So what you need to form that is some lava with a lot of gas under high pressure and a fountaining lava, and then that will form reticulite. Another thing you might see around here, probably not unless the sun comes out a bit, is Pele's hair. And Pele's hair is volcanic fiberglass, and that you have a glob of lava come out there, and because of wind and gravity, it starts to stretch. Doesn't have as much gas, so it doesn't form the foam, but it starts to stretch out, and it might get 6 inches a foot long, and it will break off. It will float around, and in the air, very, very light. It can blow for miles. And as I like to say, who knew that Pele was a blonde? In the sunlight, it looks golden. Oddly enough, we first visited the island in 1982, so there was no eruption up here. You could drive all the way around. You could hike across the caldera. Since then, we've had enough changes out there that it's not such a good idea. Okay. Particularly the collapse of 2018 made hiking out there a little bit more problematic with the new cracks and stuff.
How hot is it in the basement?
So it's going to change. Okay, so if I told you today it'd be different tomorrow, it'd be cooling off. I have walked on lava reasonably comfortably. I was only 2 weeks old. This is 9 days old. It might still be a bit warm. When I was walking on the lava that was 2 weeks old, it was down by the water because Pu'uo'o, a big vent down there about 12 miles from here, had often had flows into the water. It had been erupting for about 35 years. It also stopped in 2018, the same reason. The escape of all the magma down to Leilani Estates and the Kapoho area really robbed this area. We've had a resurgence up here as the magma came up, but Pu'uo'o, no new activity. And it's all the same volcano. So as I said, it's one of the most active in the world. It's the most active in the U.S. And because of the unfortunate war party that got wiped out, it's the most lethal in the United States. So you can tell your friends that you were inside the caldera of the most active and most lethal volcano in the United States. Okay? See if they're impressed. Any other questions? Okay, how far down is the hotspot? Okay. About 60 miles or 100 kilometers down is the top of the hotspot. We don't actually know why it's there, although there's several theories. One of which is that the heat comes up as a plume from the core and makes the hotspot hot. There are roughly 100 hotspots in the world, so it's not completely unknown. Another hotspot that people might be familiar with is Yellowstone. Yellowstone is a hotspot, and that's been, if you track the progress of the hotspot, you're actually tracking the progress of the continent. Okay, so the hotspot goes all the way over to the Pacific coast. Okay, the Snake River Valley is more or less the track of the hotspot through Idaho. You know, people worry about the next eruption at Yellowstone, and I won't say they're wrong. It's just that the last one, the last significant eruption there, was 77,000 years ago. And the last super eruption there was 640,000 years ago. So the odds are it's not going to happen this year.
How do you know how far is safe? I mean, if this thing blew tomorrow, how would you know that we were safe standing?
Well, first of all, it's unlikely to blow up. Okay, it's in an effusive mode. You could be right here watching the fountaining, and you'd be impressed, but not in danger. Between about 1490 and 1790, though, there were on and off explosive eruptions. And if we had a return of explosive eruptions, we'd probably clear the area. the geologists have a pretty good handle on that stuff. So, as we say, right now we are in an effusive period. We get a lot of flowing lava. We don't get explosions.
If you had to guess, when would you see more lava again?
In about a week, plus or minus a couple days.